Make him feel welcome.
Hello, everybody. I guess I'll be speaking kind of fast, but still, if you're gonna sleep after lunch, I'm not gonna be mad at you, so feel free to do that. I'm Łukasz Langa, and and I can be reached in multiple ways on the internet. I'll be speaking today about configuration, about configurability of your applications, but that's kind of a tricky topic, so maybe let's talk about cars. American cars, right? Americans love cars, don't they? I know I love American cars, so let me show you one. This is a car that predates Henry Ford's birth, because he was born in 1863. And this is one of the cars that actually made it possible to colonize the area where we are currently. So, thumbs up. The problem with colonization is that there is an increasing number of people wanting to get on your wagon. Yeah, okay, pun not intended. So, people were producing wagons here on site, people were importing wagons from England, and the more tricky parts of these wagons were obviously the wheels. As you can see, they're not really that much complicated, and they broke quite easily, so you had to change them. To change a wheel, you use a tool, which looked like this. It was quite a widely used tool, and very many people actually had that with their wagon. The problem was that an increasing number of wagons were imported from England, where the nuts on the wheels were of a different size. So the tool couldn't really be used to change the wheels from English wagons. Then somebody named Richard Clyburn came with a tool. It's called the English key, first invented in 1842, and independently by Edwin Burt Budding. Isn't that the case for most of the greatest inventions, that they were independently invented by somebody else? I guess that's the case. Yeah, but that's the English key, also known as the adjustable spanner, the screw wrench, and basically, I'd say it's the first example of a tool that is highly configurable. But let me just skip that subject for just a second to tell you about Robert Ampersig. If you don't know the guy, you totally should. He wrote the Zen and the Art of Motorcycle Maintenance. It's a great book. You should totally read it. And he said in the book, the solutions are all simple after you have arrived at them. But they're simple only when you already know what they are. And this is totally the case with the adjustable spanner, because once the design was known, it's totally obvious. I could actually explain my 4-year-old son how to use it and how it's constructed. It's totally easy. But before, actually, it made people worry, it made people buy multiple wrenches, so there is a certain amount of genius involved in every invention of the sort. So moving along to configuring applications, to actually computing science, let me talk about the 4 desirable characteristics of configuration. The first one is that configuration should be composable. For instance, Unix tools usually provide different levels of configuration. There are program defaults, there are operating system defaults, there are user defaults, environment specifics, and even runtime overrides. And all these levels of configuration can be used to specify the same options, but there are rules on which overrides which lets you actually manage the changing environment of your operating system by leveraging some of the configuration to the package maintainers while being able to have your own specific variants of certain configuration options. So, composability, one of those. Configuration should be readable by people, right? To distinguish when an option is enabled or it's disabled. But not only by people, also by programs, because configuration should be cheap to pass. Then you have exchangeability. So configuration should be easy to modify, store and transfer. That includes the ability for a program to write the changes back to the configuration registry, whatever that is. And last but not least, discoverability, which only means that the configuration should be self-documenting. So we have those four. Configuration that should be composable, readable, exchangeable, and discoverable. How does that look in the real world? Let me just show you a couple of usually used configuration formats and how they adhere to those characteristics. Let me start with the easiest one, I guess, or easy-ish formats, like ini. But there's a problem with ini. It's not really a standard. It's an informal standard. There are lots of variants, lots of even file extensions. You have .ini, .cfg, .conf, .cnf, whatever. And then there's all the differences between those variants, like case sensitivity, how they actually implement blank lines, comments, duplicate names, how they support escape characters, stuff like that. There's lots of variants, but there are good sides to a format like this. The good side is that it's highly composable, which is sort of implementation specific, but most of the parsers do support composability. It's readable, as long as you're consistent with your configuration, it's readable. And it's exchangeable, as long as you keep the encoding sane of your configuration files, it's kindly exchangeable. And if an option is specified, it's kind of discoverable. I mean, most of you can possibly tell what the configuration file on a slide is about. Another highly known format, not as loved as the first, is the custom Apache format, which has a great feature because it supports hierarchy, supports includes as well, and each directive is enclosed in a single line. There's this directory, var www hosts, which has this strange options. And this is one of the cases where I want to show you how even a seemingly simple format can be deceiving. What's the difference between those two option lines? Well, the first one actually forbids indexes, whereas the second one enables them. Ta-da! So, custom formats, yes. There is another widely known configuration format which Nginx uses, kind of C-ish, easier in terms of hierarchy because you have only the three hierarchies, the HTTP block, the server block, and the location block. But they kind of have number of possible contexts, the global context, the HTTP context, server context. It supports even if-else, it supports nested locations in locations, stuff like that. So it's kind of nice. Then you have JSON. This kind of worries me because Doug Crockford, when he came up with the JSON, he didn't think of it as a configuration format, more of a transmission format, so a transfer format. Whereas an increasing number of tools, mostly Node.js and friends, but also Sublime Text and other pieces of software, uses it as configuration, which has good sides because it's simple, kind of human readable, cross-platform, supports multiple languages and Unicode, but JSON doesn't support includes, doesn't support cascading, and while a JSON encoder may accept and ignore comments, it must not output comments. So it's kind of a weak format for configuration if you cannot have comments. And then is the new kid on the block, which isn't really a format yet. This is a format by Tom Preston Werner from GitHub, which I believe is the reason why there is so much interest in it in its current stage. Currently, TOML is defined by a single readme.md on GitHub, and it still changes quite rapidly. As you can see, it's basically inish, but supports a couple of data types like integers or arrays, Boolean, and even dates, curiously, and sorta wants to support the nesting as well, as you can see in the servers example, which is quite nice. But then actually you can see that this is a format that is mostly made like a wish list of the things that Tom considers good to have, which at some points conflicts with one another. For instance, he says that strings should be encoded in UTF-8, then he lets you specify arbitrary byte characters, which kind of in my book doesn't really play along. But to be honest, I don't really want to be too hard on the format yet, because it's like a month old or 2 months old. Then again, it's open source. I even have like a couple of pull requests accepted in it, so I'm kind of responsible for it now. Yeah, but still, it's in a very early shape, so I wouldn't consider it for adoption in your applications, especially that most of the Python parsers for it use really strange methods to achieve this parsing, so really, not yet. Then there are the complex formats, like XML. XML has this desirable characteristic of being validated. So you can use schema validation, which is quite nice for a configuration format as well. But we are all tired of XML not being really readable by humans. For instance, the configuration file you have on the slide is an actual configuration file from Zope, which you can see uses some peculiar formatting techniques for kind of hiding the unfamiliarity of XML. Then you have another format that wasn't really thought of as a configuration format, but rather than a transmission format. It was conceived as a data serialization language. Technically, it's a superset of JSON, supports serializing arbitrary native data structures, which Ruby guys, especially the Rails guys, use heavily, and sometimes it leads to security problems. Yeah. But it's also kind of unfamiliar. Whoever sees a file like that on the first site cannot really tell how would you extend it. I mean, if it's already kind of specified, you already see options on your file, then it's kind of readable. But how would you add a new option that's not already there? This is kind of iffy. It's iffy because, like Tom from GitHub said, the YAML specifications is 80 pages long. So it's kind of complicated. And it has this feature which we like in Python as a programming language, that it uses white space to define scopes. I would argue that in a configuration format, it's not a virtue, but a problem. Because it makes things fragile, for one thing, and makes the copy and paste ability of configuration kind of icky and fragile. Yeah. So, if we already use significant white space, why not use Python? It's composable because if you plumb enough, you can import anything. There's much power in the hands of the user now, but the user can get things wrong, especially if he's not a Python programmer. I would say that there's too much plumbing here, and if the user is not a programmer, it's kind of hard to understand. For instance, the module root part that is on the slide is what each and every Django application does to kind of specify where those files should be put. So if you're not a programmer, you're going to have a bad time actually understanding what is going on here. So these weren't really those bad formats. There is also a set of awkward formats. For instance, DSLs, like the Cucumber example on the slide, they're really formats that the users came up with themselves. So it's really a specification language dedicated to a particular problem domain, or so Wikipedia says. But technically, this is something that has trouble with deciding whether it should be a totally new format or should it base on an existing one. For instance, a very often taken approach is to extend or otherwise change the programming language that is used to pass this format later on, like you see on the Puppet example on the slide. So there is a problem of shifting domains, and then if you want to use a DSL, you might just as well specify an XML file with a schema, and it's all the same. Then there's SQLite, which I would argue is a pretty neat format configuration, but there are strings attached. For instance, Postfix really uses traditional text files for configuration, but when it comes to lists or hashes, it supports SQLite files as well, which is kind of neat, because now you are able to write tools that automate your changing of your configuration at runtime, which is really nice. Then you have the example of Mongrel 2, which stores all of its configuration in SQLite. The problem with that is that only programmers do really know how to actually change the configuration, and then it's very bad at discoverability. But Mongrel 2 came up with this great notion of ditching editing of SQLite by hand, and now provides you with a tool that's basically used to change each and every switch in your configuration. Even if you're using a text-based configuration format like Apache does, there are tools for it that make some of it easier for users, for administrators. Well, the Windows registry. So, I mean, it's composable, right? It's hierarchical and stuff, but it's not really exchangeable. It's highly Windows-specific, and moving between per program and user-specific settings is difficult. It's also a single point of failure. It's readable, sorta, but doesn't support comments. And then it is the only configuration format that sports the feature of having a market for tools that cleans them up. But it's not the worst format ever. There is one that I want to show you. Yes, the worst format ever is the one you conceive on your own, because you will impose a learning curve on your users. They will find an easier to use version of the software and ditch your application. So don't. But then your design decisions will be unintuitive for a class of your users. And the thing that you're so proud of that made this configuration format so different, this exact feature will bug your users. But it's not our greatest problem, right? The greatest problem is that you will fail at parsing, because parsing is quite tricky. So possibly not by much, but you will. That's a certainty, I'd say. And then you'll see that people start depending on the quirks of your parser. So that's a lose-lose situation, because at that point you cannot fix the bug without screwing your users. It gets even worse, because configuration written once has to be supported forever. So please select one of those formats I told you about before. They may not be perfect, but at least they are already field tested. Let me tell you a bit about seeking how much configuration should there be in your application in the first place. Because the configuration format is really like the technical detail. But how much configuration do you really want? And how should it be bootstrapped? So if your user approaches your application on the first day, how should he be confronted with configurability of your application? There's a great example of Dropbox, where Dropbox really lets you configure their server-side client in a really peculiar way. I haven't seen an example of that in the wild for any other piece of software. Basically, you wget or curl your binary, you unzip it, and then you run the Dropbox D. And all it says is that please visit a URL to link this instance to this machine, to Dropbox, right? So I would say this is perfect. It makes configuration a non-issue for new users. These are the 4 characteristics I spoke about before. But let me handle them from another perspective. We all know the excerpts from Zen of Python. Beautiful is better than ugly, simple is better than complex. Everybody knows it, everybody should know it. Flat is better than nested, surely. Readability counts. But there should be only one obvious way to do it. So I'd rather not introduce tools which look like this, but rather have tools that look like this. Actually, this is a website I want you to all use, because the world would be a totally different place if everybody used makeeverythingok.com. Changing the subject a bit. Configuration is not data. So if you want to describe behavior in your application, this is not the same thing as the things that are subject to behavior, which postfix shows you in a quite good way by separating the configuration in the text files from the hash tables, which can be, for instance, stored in SQL files. I would say that each and every one of you probably knows that hard coding is an anti-pattern, like hardwiring circuits and stuff, but also the reverse is true. So source code that is embedded in configuration is also an anti-pattern, because you have to consider testing. You have to consider debugging. When your user actually files a bug in your issue tracker, then you will have to ask him, can you please send your whole configuration along? Which is actually quite tricky. But configuration is also not code. So the thing I said, the reverse hard coding problem, which actually provides us with the whole picture, that configuration only characterizes behavior, code defines and executes it, and data is only the thing that is subject to behavior and should be stored in some sort of database. Now, quickly, Django. I don't know whether everybody uses it here, so let me practically tell you about some problems with that. Django mixes different kinds of settings, and then you have approaches how to solve this, because not all the problems are of a modular basis. Some of them are even security problems, for instance, storing passwords and the secure key. So the simplest approach is to just import a local module which stores the sensitive part of the data. But it has problems. What happens if the settings local module doesn't exist? So we have all sorts of workarounds for that, but there are alternative approaches. For instance, specifying files for different environments and then running with Django settings module. But this is kind of awkward as well. So you also have approaches like this, where we can specify configuration files like we would do in other Unix tools, so that the settings folder looks like this. We can specify all sorts of overridable settings, and they are executed in the alphabetical order. Then you have Django configurations, which I highly recommend, which make configuration a non-issue using classes to define different environments. This is really cool because you can also use mixins with it. So for instance, having your own library of possible mixins and then only compose them using multiple inheritance to get whatever the configuration looks like in the end. The only problem for that is that you have to specify two ways of configuring your application then. I would say that a flat approach like this, using ini files, would be great as well. And this is kind of something that you can rather simply implement on your own too. Having production settings in another file, then staging configuration. For instance, using config parser, you can read multiple files. Then there comes the problem of mixing file-based configuration with command line overrides. For that, I will only say use config glue. There's also conf-arg parse, but config glue is the nice part, the nice implementation. But whatever you do, please name your command line arguments on par with the file configuration settings. Because if you don't, people are gonna get confused. That kind of concludes my presentation. I also have a short detour to show off the new version of the config parser library in Python 3, which supports let me just which supports dictionary-like API. So the old ways are switched to a new, much more nicer API. It's very configurable, so you can fetch configuration from a dictionary, you can create sections from a dictionary. The output is like this. Yeah, and it supports even a build-out inspired interpolation, which is kind of nice. It's highly customizable, which is all documented on the on our website. What happens here? PowerPoint, don't do that to me. Yes, it's misconfigured, totally. Let me just switch the screen then, if it let me. Yeah, but these are basically the last slides I do have. So if there are any questions, please go ahead.